Welcome to Denver Startup Week. I'm Ben Data, co-chair of DSW. This year marks the 10-year anniversary of Denver Startup Week. This community has been the catalyst for lots of change over the past decade, and this week we're coming together to celebrate the past and dream big for the future. We are able to bring Denver Startup Week to this community thanks to our 2021 sponsors. Thank you to our HQ and title sponsor, Amazon, and our title sponsors, whose leadership makes this week come to life. Capital One Cafe, Downtown Denver Partnership, Fluid Truck, Hotel Engine, and WeWork. And our track sponsors, who have made all of the great content you're hearing today possible. Founder Track, Kickstart, Growth Track, Friday Health Plans, Developer Track, Quizlet, Product Track, Palantir, Designer Track, Battery 621 in the Public Works, People Track, Exactly, and Spotlight event sponsor, Strat Labs. Our headline event sponsors are bringing the excitement this week. Thank you to B-Side Fun, Colorado Public Radio, Comcast, Coors Brewing Company, Denver Pavilions, Entrepreneurship at the University of Denver, Gusto, JP Morgan Chase, Method, Moss Adams, Pine Insurance, Promontory Mortgage Path, Red Bull Basement, Southwest, Tattered Cover, and VF Venture Foundry. Finally, thank you to our partner and member sponsors listed on the screen. Please say thank you to these companies as you enjoy our hybrid Denver Startup Week. And don't forget to use hashtag Den Startup Week to share your experience and moments of inspiration on social media. Have a great week.
Early risers, all-nighters, slow pours, fast crams, post-nap, on the mat, in the stacks, phone down, volume up, complete silence. You ups? Coffee cups, pizza crusts, first semester, fourth quarter. Focus 100, privacy 0. Pre-test, one last check, let's go. However you study, Quizlet takes the guesswork out of your coursework. Learn it, own it, Quizlet.
Hello everyone, welcome to Denver Startup Week. I'm Connor Swanson, the Developer Track co-chair along with Aaron Clark, and member of the Denver Startup Week Organizing Committee. Thank you for joining us for the 10th anniversary of Denver Startup Week. At Denver Startup Week, we strive to make all of our sessions a space where attendees can connect, learn, and grow, regardless of age, gender identity, gender expression, race, ability, or sexual orientation. A special thank you to all of our sponsors for their support in helping us to keep DSW free and accessible for all. Thank you for joining us, and have a great week.
Hi all, Kenneth Sabir here, coming live from Sydney, where it is just past 2 a.m. So to keep my thoughts in check, I've done a pre-record, so I don't have to ramble on at 2 a.m. So we'll start that video off soon. You can feel free to contact me. You can keep my Twitter handle there, that's at Tracksuit, and my LinkedIn. But also feel free to ask questions throughout the talk. And we have the advantage of there'll be two of me, one that's talking and one that can answer questions live. So I'll answer what I can. And if there's anything special, I can answer it in person at the end of the talk. All right, let's have the video. Hello, I'm Kenny Sabir, and I am here to talk to you at Denver Startup Week Day 5 on Friday about how we created an offline time machine using event sourcing. So first we'll set the scene and cover why event sourcing was needed in AgTech. Next we will understand the basic premise of how it works and name all the bits so that you'll know what I'm talking about as we get into the detail. And finally, we'll go into the specific problems and solutions we have done. I'll go fairly quickly through the primer as it is covered in other event sourcing literature and talks, and the more unique findings are in the last section. So let's start with the big questions on how do we feed 10 billion people by 2050 without using more land while lowering emissions. The world population is growing, yet the land is not. As you see, 50% of the lands in the world is currently used for agriculture. So there's no silver bullet, but we need to improve efficiency and reduce waste across many different industries. And I chose to help improve livestock farming back in 2015. So as they teach in business school, or so I hear, I don't know, I'm an engineer, and so I'll paraphrase, to improve your business, you need to know your business. The good farmers, they love their data, as in a competitive market, that can help develop efficiencies to improve their farm. This data needs to be accurate. There's various governments that have traceability systems after what happened in the UK with the foot and mouth around 20 years ago. Or audits for certifications, for example, organic certification. More recently, the consumer is wanting information regarding where their food comes from with the paddock to plate movement. How is this data captured? In the past, it's been with whiteboards in the wool shed, pen and paper, and a notepad in the top pocket, as you see in that diagram. Or for the more brave, it was spreadsheets. It can often be a point of friction on the farm, as one farmer's out in the field doing the actual moving of the animals, putting treatments out, putting out the feed, while the other partner's at the homestead trying to do the record keeping and needs to know what's happened. So pen and paper is still a leading management tool for farmers globally. So what's the problem with that? This should be fairly obvious, so let's go through it quickly. There's no backup of the data. When it goes missing and then it turns up as you're hanging out the washing, you've just lost months of data. It's inefficient. You need to double and triple enter your data to get any meaningful insights. And it's also difficult to share the information. So for the accountant, they're like making lots of unnecessary phone calls to you, or the agronomist. And it's hard to use at scale by any third parties who are wanting more detailed information. For example, people trying to understand the carbon credits. Not only is this negatively affecting the integrity of the data, but it all adds up to a lot of wasted time as well that could be invested elsewhere. So the benefits from a digital management system, of course, you're going to get more accurate numbers, you're going to have time savings and audit ready, and it's going to lead to productivity growth, data-driven decisions, and business transparency. So we want to solve world hunger and make the world a better place. What could go wrong? Internet access, for starters. We have had some farmers who use our product. The only time they get to sync with the cloud is their fortnightly trip into town for groceries. However, for most of the customers we have, there's some sort of connection at the homestead. Not always in the paddocks, though, where the farming work is done. So why was livestock farming left behind in technology? There are some other hard problems in getting it to mobile. It needs to support backdating and offline support. The farmer needs an accurate report of their farm state, both historically, in the past, for reporting and analysis, but also in the future, for effective scenario planning. And it needs to support multiple users on the same farm, possibly editing the same animals, possibly while offline. All these challenges together make it a tricky situation. So there are challenges with backdating. So how can we predict the exact state of the farm back in time when they're entering the records that they forgot to enter? So we already use satellite imagery, so we can analyze the paddocks. We can tell you how much feed on offer there is. That's basically how tall the grass is. So we know we can help inform you when to move your herd, how many days left before you need to move them to avoid overgrazing. And when you move your herd, you need to know at that time the state of the paddocks, so you know where you're going to move them to. So there are some like offline solutions where they'll have like a queue of events that just get stored up, and then when you're back online, it will send it to the server, and the server does all the grunt work. That doesn't work for us. We need to have all the functionality available on your mobile. All the domain business logic that's crunching on the servers needs to be running on the mobile as well. So our original version that we started 7 years ago was when we created records that represented changes to the animals. For example, we have a weigh record there and a paddock and a movement record. And assets, which acted like views on, for example, the animal. So the animal data would be used when showing a summary of the animal, and the records would be used when you want to load all that animal's history. So this diagram here shows how saving new records over time update the animal view. So we start off with an animal created, and we go, okay, so our version of the animal's pretty bare bones. We've now given it a weight. Okay, so the animal's updated with a weight, and now we've moved it to paddock A, and that's has a location. Not that exciting so far. So each of these objects were updated and saved and syndicated to the other users via the cloud. Each of the other users could see the new records in the animal history and the newly updated animal view. I hope you like my blue farmers. James Cameron gave me early access to his models for Avatar 2. You can see here we have the records, the light green, and the assets going up to the cloud and coming back to each of the users. Likewise, any other user could do the same thing and update an animal by creating a record, and then both the new record and animal view would be sent back to everyone else. Here, Ali's creating a new record and updates the animal view, and it goes to everyone. Now, if the internet was always available and infinitely fast, and users were infinitely fast at entering data, there'll be no race conditions. Job done. Get some seed funding. Unfortunately, in the real world, as we got more users on board, we had race conditions and sync issues. So in this scenario, now Sally and Ali are updating data while offline. When they finally sync, Dave would get the 2 new records as expected, but only one of the animals would come down. There'll be a clash. Which one do we use and which is overridden? To understand what happened then, let's give each of these records and assets an ID. You see, for the records, we have a record 1 ID, a record 2 ID, but for the animal, we're talking about the same animal. It just has an animal 1 ID. You'd probably use a UUID hash, but I just gave some text IDs there for ease of use. So what does that mean? So now we have a conflict on the server. So when Dave is loading what's the latest, the animal's been overwritten. It depends how you're managing it, but if you're just doing the most simplistic get last mod date, you're just getting the latest animal and you've missed that current state, which means that the location is set, but the weight is not set. The weight's still at 400 instead of 450. So now we have some merge conflicts to worry about. And this isn't a simple git merge, as there sometimes needs to be business logic that can handle the merges. There are some interesting techniques for managing merge conflicts, such as conflict-free replicating data types. However, we also need to consider some user conflicts that we cannot resolve. For example, someone sells animal 1, while someone else marks it as dead. Which one is valid? As the system, we don't know, as we'll need to ask the user. But can we avoid a lot of these merges altogether? It raises the question that I often ask myself when faced with a technical problem of how did they do this in ancient Mesopotamia? That's right. It's called event sourcing, dating back to ancient Mesopotamia. In that previous system I just described, we cared about the records and the assets, so naturally we persisted them both. Event sourcing is about throwing away the asset as something that needs to be persisted, and recreating it each time by playing through the events. This is how the ship's log work. When it comes into port, the source of truth in the ship's log isn't that it says the wool is now 200 bales. It is that 50 bales were added in Sydney on this particular date. If you want to work out how much wool there is, you can simply just play through the events by adding and subtracting the bales transferred onto the ship to find the exact value at any point in time. Likewise, have you tried to withdraw money from multiple ATMs at the same time? No, me either. But if you did, the banks have figured this out too, and the financial systems are event-sourced. The source of truth is the money in and out, not the current balance. Here is the obligatory quote from Martin Fowler, who seems to have always known about all the cool things going on. Event sourcing ensures that all the changes to application state are stored as a sequence of events. So, numerous benefits of event sourcing according to the brochure. You have a complete log of every state change. Help with debugging. There's easy ways to undo things. And that can help with testing, traceability, and debuggability. The business and the data analysis of event streams. You'll have a constant stream of just the pure events coming through that you can hook up for other processing. The events are immutable. When you're creating these events, they're never deleted. So you get the benefits of immutability. And it can theoretically help with offline sync. The pain points of event sourcing. There's the complexity of it. We're used to talking about saving this particular animal. Now we're not saving the animal, we're talking about the events that are changing the animal. So it takes some time to get used to. And there's limited support from frameworks and platforms. And if you're doing a change, then you also have to break the inertia, which is a whole lot of dev time and migration time. So for starters, we started getting a lot of sync conflicts when we expanded to multi-user farms. We needed a solution. We initially went with a pseudo event sourcing solution. So our records were a little bit like events, if you squint. So we just didn't bother reading the animal asset from the database, and we recreated it at startup in memory. If a record was backdated, we could just recreate the animal asset from the records. Now Sally and Ali are just sending the records, and Dave can play through the records to work out the current view of the animal. So what are the problems? So we just use a domain object, something that the user cares about, to act like an event. One of the problems is the records are not really events. They could have sync conflicts themselves. Two people could be editing a weight record at the same time. Another problem is there's many other aspects of the system that also need event sourcing. An example for that is the paddocks. So we can do various reports based on how much land area a paddock has. Then someone changes the boundary of it. All of a sudden their reports from 2 years ago are now changed. So paddocks also need to persist at a particular point in time. It also needs to be event sourced. As we wrote our pseudo event sourcing based on those domain records, iterating over the records was highly customized. We had to know how to iterate over every particular domain object. So adding new records was a slow process. We also had a new product line as well, individual animal management. Previous to this new product line, all our animals were recorded at the herd level. So we have a herd of cattle in a particular paddock of size, 24, and you're moving them to this paddock. Individual animal management means an explosion in the amount of data, as now every one of those animals can be tracked individually for treatments, for weights, for feed. So we needed a system that we could put a lot of effort into making sure it performed. And going down the pseudo event sourcing was too slow. We needed a generic event sourcing solution. So all our assets and our records are just domain objects that are created from events. The same way event can be reused to create a way record and also to update the animal model. So what are the problems? We know we wanted a generic event sourcing system, so what are the constraints for adding one? We were a TypeScript shop. Every dev is a full stack engineer. So everything in yellow and orange in this diagram is what we've written in TypeScript. At the top is what's external facing. We are a small team of engineers, and we've been dealing with over 15 million animals over 100 million acres. We were only 8 engineers for a lot of the past 6 years, and we're now 12. I'm a strong believer in the full stack developer. Everyone can slice off features and do the front and back end as required. This can help with satisfaction and reduce communication and interface bottlenecks. People tend to gravitate to front or back end, which is fine for cross-sectional teams. However, having the full stack skills can also allow us to be more agile with a small team. For example, most of us helped migrate the whole product from Ionic 3 to 5 and Angular 7 to 12 to get it out of the way quickly. Not only are the skills shared between front and back end, but the code is as well. The same domain logic and models we create once get used across the Android, the iOS, the servers, and the Lambdas. We have shared UI code as well between the web and the mobile. So, where would event sourcing fit in here? Having the event sourcing in TypeScript will allow us to have the same code we use in our AWS server deployment as in our cross-sectional, cross-platform mobile platform. Another constraint is the complexity of our domain model. So we have a whole number of records and different views of the animals. We have tasks, paddocks, planners, management groups, enterprises, over 260 models, and 100 events so far, thousands of properties. What we'd need is to be able to support hierarchical models, where the model could have reusable children to be used in different models. And as we got into the guts, we realized we also needed hierarchical events, which we'll get to. So when we were starting out in this project, we needed to understand what's the existing literature and systems out there. 3 things that stuck out to me. Well, first, the Martin Fowler writing about it in 2005. So I believe he didn't coin the term, but he really increased its visibility in computer science, being the famous guy he is. A lot of great talks are done by Greg Young in event sourcing. The highlight is the 6-hour epic on CQRS and event sourcing. And another person from Culture Amp, Sebastian von Conrad, in 2018, he gave us a series of talks. One of the interesting things he said was it's unlikely you're going to find existing systems that cover all your needs, as this is still a fairly new market. So back then in 2018, there wasn't a TypeScript solution that worked on mobile that handled offline support or supported hierarchical aggregates and models. So we decided to roll our own, build our own. We were warned at the start by Sebastian that the basics is easy to conceive and get working. So he said, you can expect to get something up and running in a month. But there's a whole lot of complexities that come, whether they be the containers of different subject types, your archiving, your performance, a whole lot of the finer points that's hard to comprehend when first starting. And he wasn't even considering the offline sync at the time, as he called it a current problem. Expect to be happier with it in 2 years. So we'll diverge to a interesting design pattern that's arisen in the last while. That's CQRS, and that's Command Query Response Segregation. It's basically saying you're separating your reads from your writes. So typically people talk about this with eventual consistency, where you just write, and read, but it's not strictly the case. You can also get it working synchronously. So all the changes to the system are done through executing commands, and all reads to the system are decoupled by executing queries. So this fits really neatly with event sourcing. So because it's the events that are persisted, it's the commands that are creating the events, and the queries are just simply reading the events. The user doesn't need to see the events at all. They'll be getting back these aggregates. Aggregates are representing the data models because they're aggregations of events. So one of the things to think about is if you're building a system, you'll need to separate it by tenants. You don't want one farmer seeing how the other farmers are doing without permission. So all the data needs to be split by tenant IDs, so the clients cannot get access to other people's data, baked all the way into the query. And that's your commands, your aggregates, and your events. So a little command intro. The command processor will be able to execute the commands if it's valid. The command should only execute if it leaves the system in a valid state. If someone wants to sell some animals that have already been recorded as dead, then the validation should reject the command. An important thing to consider is when the command is targeted to be executed. So the default idea of a command is it just has a validate and an execute method. In event sourcing, most of the time your commands are going to be returning a series of events that are going to be persisted. So when did that command execute? Is it happening right now, or is it backdated for 2 weeks? For events, the events need to be small atomic changes that leave the system in a stable state. An aggregate may use all the events you are saving, although another aggregate may only care for one of those events. So what size data do you put in the commands versus the events? The commands, they should be mapped to the user operations. The events, you need to think about how is this piece of data going to be reused. An example for an animal, there's like multiple concepts of an animal. There's its characteristics, like its date of birth, its breed, its identity, like its visual and electronic identifiers, and its state, its weight, and whether it's been weaned or not. If you're displaying the animal details in a dialogue, then you may need to load up all those different concepts. However, if you're just doing a count of your breeds, then only the characteristics will matter. So you need to be able to split up your events to be small enough to be reusable for different types of aggregates without making a ridiculous number of events for each animal created, as that will just slow down the system for reading and writing. If you have 3 different events that make up the different facets of animal creation, it's easy to write a system where each event only relates to a single animal. However, if you're dealing with thousands of animals per farm, you may need to consider putting many animals on a single event. For example, 50 animal characteristics on a single characteristics event. That sounds straightforward, does it? Or what happens if one of those animals now needs to move? We'll get to that later. So for events, the timeline is very important. Every event is saved at a particular time in the timeline. So the timeline date is different to the creation date. If I am moving a herd of animals from 2 weeks ago, then its creation date is right now, but the timeline date will be 2 weeks ago. So you can easily have a sequence number that's incrementing, that's giving a order of when these events were created. So when you're querying the events, there's different ways how you could order it. If you're making an aggregate, then you want to be able to query it through the timeline. If you're doing sync, then you'll be querying it through the sequence number. Just a little point on the naming of these two things. Between a command and event. A command is you're giving an order. It's like move this herd of animals. So it's basically a request because there has to be validation on it. It may fail. So you name it with an imperative verb. Do this thing. Move this herd. An event you treat like it's happened in the past. Herd moved. By the time it gets to being saved as an event, you know that it's valid in the system. It's basically a statement of the facts. It does not fail. So, as I mentioned before, the aggregates are basically an aggregation of events, and that's what we call our data models that we return back. They're not persisted by default, except for projections, we'll talk about later. They represent the data model to be used by the client. It's easy to create multiple aggregates as different views of the same subject matter. And here we go. This little diagram there's two things about this diagram I need to talk about. JSON and the aggregates. The first thing is we made the mistake of making our aggregates too complex, in that we were making them class instantiations, like instances of objects. And the JavaScript is fast at creating instances of classes. However, it's actually painfully slow at converting existing JSON to fit into a class object. And that's going to happen later as you start loading snapshots back from the database, especially when there's a class hierarchy. So our advice is keep the aggregates as simple as possible, a POJO term coming from the Java background, as it will help with speed later on. The second thing about this diagram is aggregates act like ancient gods in JSON and the Argonauts, and that they only exist if someone believes in them or queries for them. It's because it's the events that are persisted. You could have thousands of different aggregates. It will not affect the performance, as they're not triggered unless you query for them. It does, however, affect when in regards to caching and projections, which we'll get to later. I'm now introducing the idea of subjects. So subjects is what I like to call to name the real thing of what these aggregates are talking about. So if you think of aggregates as a view of the data, the subject is what is the real object about. For animal characteristics is the aggregate, the subject is animal. Likewise, animal identity is still animal. A way record, because the same animal can have multiple records, needs a different subject type. So that will be a subject type of way record. So this will become more useful later to be able to automatically wire up things between the events and the aggregates. It will help with the managing of the life cycle of your aggregates, on how they are created and how they are deleted or destroyed. For example, if an animal is created, then it can apply to the animal characteristics and its animal state. Likewise when it's deleted. And it will also help for managing child aggregates. And now we'll move to the event handlers. So how do these aggregates get populated with the events? It's through the event handlers. So at some point we need a definition of the aggregate, since we want to make the aggregate itself a pure POJO, a simple JSON object. So the definition will hold information like its aggregate type, its subject, which is its property name. That's going to be the subject property name. The tenant scope. The tenant could be scoped at various points. It could be the tenant is the farm. So every ID in the tenant ID represents to a farm ID. Or you might want to have one that's cross-farm at the organization level. At that point, the tenant scope is organization. And the version of the aggregate. The event handlers, they have a link between the event type and the aggregate type. So they'll have two functions. One is a can handle, and the other one is the handler. So a can handle will determine if a particular event is valid for an aggregate, and the handler will actually do the handling of that event. And what it does, it basically copies that event data straight to the aggregate. No logic, no business logic, just as dumb as possible. So we just talked about a bunch of stuff, a little summary of how they all fit together. We have commands, events, and aggregates, and with their event handlers. So the commands is the user operations, for someone just moved a herd. That in turn may make up multiple events. So you might split off a few animals off the original herd, 20 out of 100, for example, split off. You're moving them to paddock B, and then you're merging them into the other animals that are already in paddock B. That's an example of how you could develop your events. Each of the events can apply to one or more aggregates. For example, splitting it off the herd means that the original herd changes size, and we just created the new herd of 20. or it could affect different aggregates. For example, when you move it, we are changing the location on that new herd, plus we're also updating other information on the paddock aggregates. So now you're making events willy-nilly, and you start getting a whole lot of events and things start to slow down. This is what happens. How can this scale? Over time, this will just keep on, build an aggregate, you're just getting more and more of events. So now we bring in the concept of snapshots. So snapshots is basically a copy of an aggregate at a particular point in time. And all the events that happen after that will just be played on top of your snapshot. So they can be triggered different ways on when they're actually created. You can make it time-based, like every quarter or every day, or batch-based, like every 500 relevant events. Or you can make it like based on usage. Like when the read model queries it and it realizes that it's actually slow, it will asynchronously fire off something saying, hey, this is a slow one, let's create snapshots for it. The read still comes back fast. One aggregate can support different types of snapshots. So snapshots are not precious. You can throw them away. We don't care about them. You get a new event that's backdated. You just delete all the snapshots after that date, and then you can recreate them. And that brings us to projections. So the really powerful thing in event sourcing is you can query the system at any point in time. However, most of the queries in normal usage is understanding the system right now. So we can use that to our advantage, and we can make like this snapshot where its time is moving, and it's moving because the time is right now. So what that means is whenever an event gets saved, we can automatically update the projections that it affects. So when you're querying your animal projections is showing you the valid animal right now. It's like, here's one I prepared earlier. This is what you wanted to. This is what you're going to query, and I've already prepared it for you. So how do these get triggered? You can set up like a basic rules engine. I call them aggregate rules. And they're simple rules where we can listen to the events coming through, the new events coming through, and have different rules to handle different scenarios. Some of the scenarios could be snapshot invalidation, updating projections, or archiving, we'll get to later, or exporting. Rules could theoretically be asynchronous or synchronous, or you could have them execute only on the server, only on the mobile, or both. So queries, there's two main types of queries. You can search for all of a particular aggregate, for example, search me for all the animals, or search for animals of a particular ID or IDs. How these queries work is you have a query processor, and based on the time, we'll first see if we can pre-populate any of the aggregates, looking at the snapshots and projections and the aggregate rules. And anything left over, we'll have to play through the events. So we have an event stream player that will get the events and update our aggregate. So it's a summary of the concept so far. So we have the command that's based on the user operations, the events, the small reusable chunks of work that keep the system in a stable state, the aggregates, which is the data objects you care about coming back out, the event handlers, how to change the aggregates, the snapshots, which is an aggregate at a particular point in time, and a projection, which is like a snapshot right now. Now we'll get to the deeper look. So, what were the issues that came up when developing an event sourcing system? One is, how do we send information between tenants? Another one is, how do you really edit and delete items? How do you deal with all the performance issues? How do you sync? And a whole lot of other exciting stuff like archiving, testing, and data warehousing. So going into commands in a bit more detail, commands, you can also support chaining other commands together. So when one command completes successfully, you can launch another command. And we needed this for being able to execute on other tenants. So an example of this is you're doing a farm transfer of some animals. You're moving them from farm A to farm B. You basically want to put something in an outbox in farm A and put it in the inbox in farm B. So how do you do this? You cannot get access to farm B, the other tenant, on the mobile. That's a security flaw, because that would mean people could disassemble it and start writing anything to other people's farms. How we solve this is we use this concept of a global tenant context that's executed only on the server. So this was the space where the information can change between tenants. It's the only allowed space. So it can do all the security checks as needed in the global scope. And to get it to be able to execute a new command, we could chain it. So it executes on the global command, and then we chain to say, now if this completes successfully, execute this next command on the destination farm by chaining the different commands together. So how are events replaced and deleted? If events are never deleted, what happens if you make a mistake? How do you edit something or change its states? We added two different fields here. One is called system type and the other one's target sequence. Okay, this is an example of saying I need to update something. So I'm saying there's a system type of replace, and I wanted to change this value, that sequence 1, to 4 instead of 5. I've added a new row and saying the system type is now replacing target sequence 1. So now we know what the new value is. So how do you delete something then? That oops, row 3 I need to get rid of. Likewise, system type of delete, I'm targeting sequence 3. A trickier one is how do you actually edit the time of one. Now, we'll go into a bit more detail in the next few slides when we talk about how we're iterating events, but basically, to get something scalable, we have to query the events a little bit at a time. So we're querying up to a certain point in time. So how do we know if this event is invalid? What you have to do is you have to mark it as deleted at that particular time. And then you can create a new event at a later time. So this is saying I want to change this one from time 100 to time 150. I delete the one at 100 and I create a new one at 150. So given all that, we should just have 3 events. So this is what the end result of, after you've gone through all the system type handling, this is what you'll be left with, those 3 events. So that's all fine, but that's talking about the event level. But how do you actually delete a aggregate? So I have a way record and I want to change its state. There is some, we have the 3 separate things. We have the command, the events, and the aggregates. You can actually write your commands to have some knowledge of their aggregates on how they get created as a domain object. So not all the commands have to be like that, but for creating your base entities, that has some advantages. So given an existing way record, that will allow us to create a special replace command. So what this takes is the new way record that you want to update with. And what it does is a few steps. Firstly, it would load the original record, the one that you're going to replace, as part of its command verification step. That's an async operation. An event log is basically just all the events that were used to construct an aggregate. So you have all the original events that are candidates for replace. Next is you execute the original command that was used to create those events, but you call it using the new way record. So that will give you some temporary new events. Now you can compare the new events to the existing ones, the ones you got out of the event log, and you can figure out what's the difference, what's new, what's obsolete, what's updated, and what's exactly the same. From there, you can, as we showed before, use the system types based on those three things to be able to replace the updated ones, or delete the ones that are obsolete, or add new events, or ignore the ones that are exactly the same. So there's other system types you can think about. You can have undo, and you can do patch as well. Just say you have 100 animals in one event and you want to tweak one of them. Instead of writing all 100 of animals again, you just do a patch it. Or you could do a negative patch, and this is a concept that we came up with, where just say you have 100 animals and you want to move one of them to the next day. Instead of rewriting that event with now 99 animals, you can just do a negative patch, which is just saying this animal is removed from that collection. And you can create a new event on the next day for that one animal. So let's talk about event loading. One of the beautiful patterns you can use is cascading iterators. So an iterator at its foundation is very simple. It's simply a tool of how to get the next item in a list. But what can make them really powerful is when you cascade them together. So then you can have iterators that have different concepts, for example, that have different purposes. For example, here we have, first up, we have a paging iterator, or a streaming iterator, if your DB supports it. And its job is just getting events from the database. Maybe you're doing them in chunks of 500 or 5,000. Just getting 500 events at once. And then now when the next iterator, which has a link to the upstream iterator, calls next, the paging iterator is just giving it an event at a time. So this doesn't need to know anything about the database or paging or anything like that. So this next iterator is the system type handler. That's doing all that processing of the deletes and the replaces, as we talked about before. So this is because all the events are coming back in time order. We're figuring out the exact ones we need to replace because we're loading them all up at the same time. This has a cache of all the events at the same time. Downstream from there, you may want something like a migration iterator, inline migration, where maybe you've tweaked some data. You can't be bothered changing all the data in the database. You just make a inline migration that it just tweaks the data for particular events. So it comes to our next problem with performance is, what kind of iterators are we using? Are they sync iterators or async? Well, fundamentally, there has to be something async about them because we have to hit the database. We have to wait for the database to come back. So there's some I/O going on at that point. Problem with async iterators is they're incredibly slow. They are, every time, as we're dealing with JavaScript, every time you are iterating through an async iteration, it's using the next hit on the event loop. So you're doing thousands of events, all of a sudden it takes a very long time. So what can we do in between? And we came up with this new concept called Pausable Iterators. So at the top right here we see this is the basic definition of what an iterator returns. There's something that says done, whether it's finished, and the value of what's the next item. It's not exactly that, I just tweaked it to make it look like that. That's roughly what you get. So we added a new concept, which is a wait. Now, if you're getting 500 events at a time, we can treat this like a synchronous iterator. So it can be fast. And most of the time, this wait is null. So it's returning the event straight away. Now, if the wait's ever populated, then that can be passed back through the cascading iterators, and you can just do a wait at that point. So you can get 500 events at a time, then you do one wait, then you can get the next 500 events. So we can now talk about event subject mapping. We just talked before about the subject type on the aggregate definition. We can also add that same mapping for events. an event might have a property, for example, animal ID or animal IDs. So we can map that to the subject type of animal. This will give us some rich linking between the events and the aggregates. And if we can get hierarchical events working, then we only have to do this once at the parent for all animal events. Likewise, once for all paddock events. This can also be helpful when building the special case of events used for creating or deleting the domain objects. Now going into some detail on what the aggregates look like. Once you start using snapshots and projections, now the versions is very important. If you start tweaking your aggregate, adding extra properties, changing the properties, now all your snapshots and projections are out of date. So you need to be able to keep track of your versions. An easy way to do this is just make a new aggregate and increment its version number. Then we recommend using decorators so you can keep the metadata close to the domain object. You can see here we've indicated this is the particular subject ID, animal IDs, and the subject type, which is subject animals. And we'll go into the can-handle subject later. So one thing we found was when I talked about aggregates, it had the two functions, the can-handle and the handler. The can-handle is very slow. Look at this scenario. So we're iterating over a bunch of events. These events here keep creating new aggregates. For example, new animal, new animal, new animal. And these events here must be like ways, for example. So we're just like getting different way events. We have to find out which animal is it for. So look what happens. By the time you get up to here, you get an event, and you have to run can-handle on each of your different aggregates to find out, is this aggregate appropriate for this event? No? Oh, how about this one? No? Keep on going. Finally, we find the right aggregate for the event. As you can see, this scales really bad as you get thousands of aggregates. If you're returning like a large list, for every new event, you have to iterate many things. So we introduced the concept of can-handle subject. So this is like the can-handle function, but it's basically turning it into an index. Most of the logic in can-handle is very simple. Typically, you're just checking, does this event ID of animal ID match my aggregate animal ID? If so, yes. So instead of making that a function, you can actually just index it in maps. And this indexing happens at the point that the aggregate's added to the system. As soon as you get a new animal, initially scan it for every possible event that it's going to have, and you index it, saying, first you index it by event type, you index it by subject type, and then you index it by the subject ID itself. What this allows is now when you're looking at a new event, you can instantly drill down these maps and find the exact handler container that's relevant for that particular event. And that can be, multiple aggregates. Potentially, it could be a list, but it dramatically speed up the system. Okay, now we'll talk about how we did sync. There's two ways of doing sync, two phases, I should say. The first way is very easy, and that's just sync everything. Sync the events and commands both ways. So both the mobile and the server is creating events and commands. Just sync them all. You dramatically reduce the amount of sync conflicts because you're not actually syncing the domain objects, you're syncing these events that make up the domain object. So you're halfway there. You get rid of most of your the sync conflicts we were experiencing previously. The second phase is a more complicated sync. And this is a highly specialized events sourcing sync that we're still experimenting with. And this is the idea of only syncing down the events and only syncing up the new commands from your mobile. So what that means is the server becomes the source of truth for command validation. Even though it's executed, the command's executed on the mobile, it isn't legit unless the server says it's legit. Now this might look a little scary, we'll just talk about it here. Let's start on the top right. The user creates a new command. Okay, we create some temporary events for the new command, and we'll save them. We're not putting them in our main event store. We're putting them on this little sidekick event store called the local event store. And we've marked this command. We've said, okay, added this to a queue. Okay. Over on the top left, we have this sync loop. What this says is, oh, find the latest event sequence number we have currently. Okay, great. Now request all the events since then. So normally that will just go and find the events that other people have added. Okay, great. Okay, insert them in here. Okay, but another thing it does is that we also pass up the new commands that are in the system. Now, what we do with those commands is we execute them on the server if they're valid. If they're not valid, they'll get rejected. I've hidden the validation code from here to keep it simple. But if it is valid, we execute it and we create the events. These events get saved in the database. Now we go to the second phase, which now get me all the events since this sequence number. Magically, that's going to also include these new events we just saved. All these new events come back down to the system, they come down into the main event store, and now we can also delete the events by command ID out of the local store for the ones that are successful. As the system grows, you're going to have lots of events. The two different things to think about for archiving is the client archiving. And that is where you could say, you can set a particular date in the past and say, I'm just going to blow away all events before this date. To make your life easier, I might make a bunch of snapshots at that date on common aggregates that you care about. But it also means that you're going to restrict editing before that date. So maybe you want to make a 6-month period or a financial year period and say you can't edit anything before that financial year, but you can still see the full history of the animal because we've created snapshots for it. Server archiving is pretty straightforward. It's just partitioning off the events as well. Whether you can do that, likewise by financial year or other concepts, and you can also make server snapshots similar to the client snapshots, so you don't even have to look in those previous archives. And it can still be accessible to query the previous ones if you need to for some reason. For testing, I suggest making a nice flexible framework for testing. This is an example of our framework. So given these events, when you have this command, expect these events. So in this case, 2 new events are getting added. You can also expect this aggregates by an ID search and these aggregates in a normal search. By flexible, I mean maybe you just want to test the aggregate creation. So you don't have any commands or expect aggregates. Then you just go, given these events, expect these aggregates. So you should better use those different items in different permutations and get some useful results. And lastly, a quick note on data warehousing. When we were building this system, one of the things Greg Young mentioned was that a whole lot of talk in event sourcing is talking about asynchronous solutions, talking about what databases and what queues and streams are using. There's a whole lot you need to think about in event sourcing before you get there, so you can actually get it all working as a synchronous system. And that's what we did. After you start adding a lot of projections, then every time you save a command, there's a whole lot of projections you need to update. And that doesn't really scale well as a synchronous system. So at that point, you got to start looking at queues or streams. We have Kinesis running here. So as all the events are persisted, for one, they get saved in the database first, and then we throw them onto this Kinesis stream, data stream. From there, our rules can listen to that, and we can make like export rules for every different aggregate we care about and throw it onto a data stream. So the difference here, this is events and this is our aggregates. From there, they can go straight to Firehose down into S3. And from there, we can send it wherever, Snowflake, for example. All right, and that's the end. And I will answer questions in person. Thanks, guys. So I've answered some questions on the Q&A. If there's any last-minute questions, get them in right now. But we're coming to the time, so thank you all for joining this session on event sourcing and seeing what we're doing at AgriWebb and working with livestock producers to feed the world more profitably, efficiently, and sustainably. Feel free to contact me to continue the conversation. There's my Twitter and LinkedIn there. And have a great rest of your Denver